Hey, and welcome to Unit 13, Day 6 notes. Today we're comparing linear and exponential functions. We're considering two options to save money here. Y represents the total amount of money in the account, and X represents the time that it is in the account. For option number 1, you start with $25, and every year you add $100 to your savings account. We want to write the equation for this problem. Since we're adding money every year, we know that this is going to be a linear function, and that can be represented as y equals 100x plus 25, where 25 is my initial amount and I'm adding $100 every year. For option number 2, we start with $25 and double the amount of money that we invest every year. Remember when we were talking about exponential functions, we had the keywords that would let us know if we had an exponential function. We have one of those keywords here, and it's double. So we know that we'll be using this form for exponential. To write my exponential equation, I start with my initial amount, which is A, or 25. And it's doubling every year. So 2 is the number that goes with double, and x in the exponent to make it a true exponential equation. Now we want to graph both of these on the same graph to see which one is going to suit us best. So for option number 1, we started with $25 and we added 100 every year. So after 1 year, we'll have 125. 2 years is 225, 3 years, 325, and so on. Now we want to look at option 2. We started with $25 and we double every year. So after 1 year, we would double and be 50. 2 years would be 100. Double to 200. 400, 800, and 1600. And we'll go ahead and graph these. Here is my line for option 1. Oops. Now we want to do the same thing for option 2. If I was going off to college in 3 years, which option would you choose? So we would look at the line on our table that says 3 for 3 years. So if you were going in 3 years, which option would you choose? You would choose the one with the most money, and that would be option number 1. You would have $325 at that time. When is option number 2 a better option? So that's basically asking me, when is option number 2 going to give me more money? So it does not give me more money until after 5 years. After 5 years, you can see that I have significantly more money than option number 1. For the short term, option number 1 would be the best choice. For the long term, option number 2. Which one is a linear situation? So which one goes up in a linear fashion? We already talked about that up top. That was option number 1. Option number 1 goes up in a linear fashion, and when you graph it, it is a straight line. Option number 2 is an exponential function because it is growing at an exponential rate. Now we're going to move on to the matching activity for day 6. You've probably seen the matching activity in your packet. It has situation A through J and graphs 1 through 10. This is what it should begin to start off looking like. So situation A, you hire a taxi and you pay $4 to get in the car and $3 per mile. We want to write an equation that represents this situation. In this case, it would be y equals 3x plus 4. $3 per mile plus the initial fee of $4. Situation B, you have $4 in your piggy bank, which triples every year. Notice that you have that keyword triples, which should indicate to you that this will be an exponential function. So my equation will be y equals, and my initial amount, which is $4, and that is tripling every year. Your parents pay you $4 a week for allowance plus 50 cents for each chore that you do. So you get 50 cents per chore plus your initial allowance of $4. You're 4 miles from your date's house. You walk half the distance there. Then you walk half the remaining distance. Then you walk half the remaining distance. You do this forever. Technically, you never get there. So, since it says technically you never get there, that should remind you of an exponential function. Because remember, in exponential functions, we have asymptotes that we are approaching, but we'll never get there. And then the key word that we see here over and over again is half. So we'll start with our initial distance, which is 4 miles, and then we walk half the distance every time. All right, situation E. Your wonderful math teacher gives you 3 M&Ms at the beginning of class and 4 additional M&Ms for each correct answer on your homework. So you start with 3 M&Ms and you get 4 for each right answer. You start with 3 plus 4 per every right answer. Situation F. A population of cockroaches in a school's kitchen, not yours of course, starts with just 3 cockroaches and it quadruples each week. We have that key word quadruples, which means that we'll have an exponential function. We start with our initial amount of 3, quadruples goes with 4 to the x power. Situation G. It takes you 30 minutes to set up the sunglasses, etc. kiosk in the middle of the mall, and then you work there 4 hours per day. One thing that you need to notice here is one measurement is in minutes and one measurement is in hours. So we want to make sure that all of our measurements are the same when we write an equation. So we will put all of these in hours. We'll change this 30 minutes to 1/2 hour. So when I write my equation, I get y equals 4x plus 1/2. Situation H. You have half a gallon of water in the kiddie pool, and as you fill it, the volume quadruples each hour. We have our keyword here of quadruples, which means that this is going to be exponential. We start with our initial amount, quadruples every hour. And the last two, situation I. You have $5 that you put into an account and you deposit $2 every Friday. So $2 every Friday plus your initial amount of $5. And then last, situation J. You have $5 that you put into an account that doubles each year. Doubles is our key word here to let us know that it's exponential. So we start with our initial amount and we double it every year. There we go. Now we want to match all of these to a graph. So graph number 1 is a linear graph because it's a straight line. We want to match this with one of these situations that we had previously. We see that our y-intercept is 5 and our slope is 2. So we're looking for an equation that is y equals 2x plus 5, which we see right here in situation I. Graph number 2 is an exponential graph, and we see that our starting point right there is at 1/2. And we see that our b value is going to be greater than 1 because our our graph is increasing. So we need to look for an exponential function that has an a value of 1/2 and our b greater than 1. My a value here is 5, so that doesn't work. My a value here is 1/2 and my b value is greater than 1. So situation H will work in this case. Oops. Situation H. Now we move on to graph number 3. We see that we're starting right here at an a value of 4, and my b value is going to be greater than 1 here because it's an exponential growth graph. My a value is 5, doesn't work. My a value is 3, doesn't work. My a value is 4 in both of these, which is what I was looking for. However, I needed a graph that was increasing, and that'll be situation B. Graph number 4 has a starting value of 3. And we know that our b value is greater than 1 because it is an exponential growth again. So here we have a start value of 3 and a b that is greater than 1. So F works in this case. And there we go. Graph number 5 is a linear graph, which starts at 4 and has a slope of 1/2. So we're looking for an equation, y equals 1/2 x plus 4. This is not written the same way that I wrote my equation, but we know that 0.5 is the same thing as 1/2. So situation C will work in this case.